These are the parts I used to make the dome lamp dimmer circuit. The 12 volt power source on my board, I'll be using a 3.5 millimeter power jack. This is an actual dome lamp from a car that I got at the auto store. This is the 2N3055 transistor and a little heat sink that I put on it because it gets very hot. This is a 10K ohm potentiometer, which is basically a variable resistor. Here's the proto board. This is an integrated circuit, and the part number is LM741. Here is the 22 microfarad capacitor that's required, and this is the 200K ohm potentiometer, which is basically another variable resistor, and the 10K ohm resistor. For this circuit, I'll be using a push to on switch, which is opposite of a standard door switch, which would be push to off, but I'll be mounting this to my circuit board to demonstrate the function. V1 represents the vehicle's battery. This S1 represents the door switch. When it is open, when the door is open, this switch is closed, and when the door is closed, this switch is open. And here is your vehicle dome lamp. When the door is opened, the switch is closed. Voltage flows from the vehicle battery and quickly charges this 22 microfarad capacitor. As you can see, there are no resistors that would limit the speed that it charges. At the same time, voltage is flowing into pin 3 of the integrated circuit, and the integrated circuit it receives power on pin 7 and ground on pin 4, which keeps it powered, and then does whatever it does inside and sends out this voltage signal through this 10K ohm potentiometer and into the base of the transistor. When this transistor receives this voltage signal, it completes the circuit through it from the battery through the bulb to ground, which causes the lamp to burn. The adjustment of the 10K ohm potentiometer determines the brightness of the dome lamp when the door is opened. When the door is closed, it opens the switch, and the voltage stored in this capacitor begins to discharge through these resistors, the 10K ohm resistor and the 200K potentiometer, to ground. The adjustment of this potentiometer determines the speed at which this capacitor discharges. As you can see, it's discharging now. As this signal into the integrated circuit drops, so does this signal out of the integrated circuit through this potentiometer and into this transistor. As the voltage signal starts to drop on this transistor, the transistor's gate slowly closes off this circuit to ground and causes the dome lamp to slowly dim until it finally turns off. If you're wondering why this circuit is so complex and why you can't just put a capacitor in line with the bulb somehow, it would require an extremely large capacitor. With this circuit, it allows you to use a very small capacitor and just monitor. The integrated circuit simply monitors the discharge rate and transfers that into another slow-moving signal through the potentiometer and into this transistor. The transistor being slowly closing is actually what's dimming the bulb. It's not the capacitor itself. If you tried to use this capacitor to slowly dim the bulb, you might not even see a flicker of light because there's such a small amount of voltage stored in that capacitor. Here's my finished project. Here is the switch that I mounted to simulate a door switch. I also mounted the dome lamp itself to the board just for the demonstration. You can see the 22 microfarad capacitor here, the 10K ohm resistor. This is the 220K ohm potentiometer, and here is the transistor. And this transistor may look a little different to some of you. It only has 2 pins. The case itself is actually the collector, if I'm correct on that, and I put a heat sink on it because it gets pretty hot. Here you can see the integrated circuit, and this is the 10K ohm potentiometer, and this is a 3.5 millimeter jack so that I can plug my power supply in and demonstrate how this circuit works. Plug the circuit in to the power supply, and the switch is actually a push to on switch, which is the opposite of what you would have on your car door, but I put this switch in here to make demonstration a little bit easier on the circuit board here. Here's a shot of the back of the board of the work I had to do to connect all the components. And we'll go ahead and turn this on. Now you close the door and your dome lamp slowly dims. So it works pretty well. And I'll demonstrate the adjustment of this potentiometer. I'll turn it down some, and you see that it dims much quicker. And if I turn it all the way down, it'll go off fairly quickly. I like to turn it all the way up and let it slowly go down. The other thing I could demonstrate for you is the 10K ohm potentiometer. When the light is on, you can adjust the brightness. I like it to be fairly bright, so I turn it up to about right there. And that's how this circuit works.